Hello students, welcome to another Intro to Geometry video. In this video we're going to be talking about right triangles from lesson 3.6. This is something I think most of us are pretty familiar with, the idea of a right triangle. I have drawn one here. A right triangle obviously is just a triangle that has one right angle in it. Okay, so there's a right angle here. It is almost always, or should be always, marked with one of these little boxes in the angle that shows that that angle there is 90 degrees. It's square. It would make a square. So that's our symbol for a right angle, and a right triangle is just showing that there is this box in one of our corners. Okay. Now, before we get into sort of the math that we're going to do today, a little bit of vocabulary for us that, again, I think we have some familiarity with. One of those vocabulary words is the idea of a hypotenuse. Okay, hypotenuse is the side of the right triangle that is all the way across from the 90-degree angle. Okay, so if I go from the 90-degree angle, from the box angle all the way across, the slanty side that does not meet at the right angle is the hypotenuse, okay, the hypotenuse. The other two sides are both called legs, okay? So we have a leg here, and then we also have a leg over here. Okay, and both of these are both legs of a right triangle, okay? So in a right triangle, we have a hypotenuse that's all the way across from the 90-degree angle. The two sides that meet at that 90-degree angle are called legs. Okay, so make sure that that ends up somewhere in your notes. There is some stuff in your book about naming the hypotenuse and the legs with segments. We're not going to worry too much about that, just so long as we know where each one is and what each one is referring to. Okay, so I'm going to get rid of those vocabulary words now and that arrow as well. And now the main goal of today's video is to practice the Pythagorean Theorem. Okay, now this is something that we talk about back in middle school, 8th grade, possibly 7th grade. I'm not sure exactly when the first time is that we see it, but the Pythagorean Theorem is a formula that allows us to relate the three sides of a right triangle. Okay, Pythagorean Theorem, it is important to note, okay, so I'll put a little star here. Oops, I'll put a little star here. Only works for right triangles. Okay, so that's why we've specifically mapped out a right triangle. We discussed some vocabulary specifically for right triangles. So it is important to note that the Pythagorean Theorem and everything that we're doing today only works for right triangles. Okay, so the Pythagorean Theorem, which only works for right triangles, is the following formula. Okay, it says a squared plus b squared, I'll put the squareds in there in a second, equals c squared. Okay, so not just a plus b equals c, but specifically a squared plus b squared equals c squared. Okay, so it's the square of all these things. And now the a, b, and c, the a and b from that formula are the two legs of our right triangle. Okay, our legs of the right triangle. And then c is the hypotenuse. All right, so a and b in that formula are the legs of the right triangle, and then c is the hypotenuse. So I'll leave that right there, okay? So what this allows us to do is it allows us to find the value, or the length, I should say, the length of any side of a right triangle as long as we know the other two, okay? So if we look at an example and we start to do some of the math here, let's say, for example, that I knew this leg measured, let's say, 3 inches, okay? And I know that this leg down here measures, let's say, 4 inches. The question is, what is the length of this side right here, this hypotenuse side? Okay, what is the length of the hypotenuse? We can use this little formula, a squared plus b squared equals c squared, to find that value. Okay, so what we can do is we can set this up. We can set up 3 squared, because that's one of my legs, plus 4 squared is equal to question mark squared. Now, instead of question mark, I'm probably going to put an X, because that's generally what we use for unknown values. But again, I'm going to square these, 3 squared, 4 squared, X squared. They're all squared. Okay, they're all squared. So if I just start to do this math, I can start to do some of this stuff, I hope. 3 squared I know is 9. Hopefully you know 3 squared is 9 as well. Otherwise, you can use a calculator, certainly. 3 squared is 9. 4 squared is 16. So when I add those two things together, I'm going to get this x squared value. Okay, I'm going to get this x squared value. So let's see if I take that. Okay, that's all right. We'll just draw it on there again. X squared. Okay, so 9 plus 16 is equal to x squared. 9 plus 16 we know is 25. That's equal to x squared. So I know that whatever that hypotenuse length is, that question mark, this unknown up here, whatever that length is, I know that when I square it, it needs to equal 25. So in order to figure out what that value is, I'm going to unsquare both sides of this equation. I'm going to unsquare this value right here, this 25. To unsquare something, we take it and we square root the 25. Okay, we also square root this other side here, but all that does is cancel out the squared part, and we're just left with x. So as long as we know the square root of 25, or we know how to find it with a calculator, we can find what that hypotenuse length is. In this particular case, it's 5. Okay, so we end up here at 5 is equal to x, or x equals 5. So this question mark up here, I can erase the question mark, and I can say instead, I know that that side length is 5. Okay, and I found that with this Pythagorean theorem formula, a squared plus b squared equals c squared. Okay, now one more example for you. I'm not going to go through all of the math necessarily, but I will sort of show you how the setup would work. If instead of the 4, the 3, and the 5, if instead, let's say I knew that this value was 13, and I knew that this value was 5. Okay, so now I have one leg that's 5 whatever, inches or feet or miles or whatever. And I have a hypotenuse length that's 13. Now remember, the hypotenuse has to be c. So the 13 is going to be this side of my equal sign. So I'm going to have this set up now. 13 squared. And then the other side is going to have, well, I know one leg is 5, but my other leg is unknown. So I'm going to use x, again, as an unknown value. Or you can just leave either the a or the b as the unknown if you want. But I'm going to use x as my unknown. So I know 5 squared plus my unknown value squared. Okay, that's going to be this guy right down here, x unknown. I don't know what that is yet. 5 squared plus x squared equals 13 squared. Now again, I can do some math. 13 squared is 169. Okay, I know 5 squared is 25. And I still have this plus x squared business here, plus x squared. 25 plus x squared equals 169. Now this equation, I have to recognize I not only have my x value squared, but I have it added to 25. So if I'm going to get the x all alone and figure out what it actually equals by itself, the first thing I need to do is minus away the 25. So I'm going to minus away this 25 on both sides, just going back to basic algebra, solving these equations. That 25 is gone. X squared is equal to 169 minus 25 leaves me 144. If I were to unsquare it then, square root of 144 will give me the x value. That'll cancel out the squared. So x in this case is going to equal 12. Okay, so I can find a leg of the triangle as well by just doing a little bit more algebra work, doing a subtraction instead of an addition when I work through my Pythagorean theorem. But this formula here should allow you to set up an equation that will allow you to find any missing side of a triangle, either A, B, or C, regardless, okay? If you have questions, please let me know. Otherwise, that's all I have for you in this video. Have a good one. We'll see you soon.